Now we're going to use the substitution method. It's another method to solve systems of equations. On letter A, it says previous skills you will need. So on number 1, it says find the value of y when x is -5. So we're going to put a -5 right here where your x is. So 3 times -5 is -15, plus 4y equals 9. It's just a two-step equation where we add 15 to both sides. So we're going to get 4y is equal to 24. Divide both sides by 4. And y is equal to 6. Problem 2, does the point work in the equation? So the point -2, 5. Does it work in the both equations? So we're going to have -3 times -2 is 6 minus 5. Does that give us 1? Yes, it does. That checked out. And then on the second equation, -4 times -2 is 8. Plus 2 times 5 is 10. Is 8 plus 10 equal to 2? No, it is not. So therefore, the order pair -2, 5 is not a solution. Remember, it has to work out in both equations in order for it to be a solution. Problem 3, solve the equation for x. So we're going to distribute, hippity-hoppity, distributive property. So 2 times x is 2x, 2 plus 5 is 10. Minus 5x equals -8. Then I'm going to combine my like terms, the 2x minus 5x, that gives me -3x, plus 10 equals -8. Subtract 10 from both sides. So -3x equals -18. Divide both sides by -3, and x is equal to 6. All right, so now we're going to head on down to steps for solving systems using the substitution method. So on this situation, it says, this is the last method in solving systems of equations. We have graphed and eliminated. So on this one, on step number 1, what we're going to do is look for the equation that has y equals or x equals. So basically, one of the variables needs to be isolated. Then we're going to substitute that equation into the other equation. And step 2, solve the new equation. Step 3, substitute the answer back in to the other part of your XY solution. So let's go ahead and take a look at example 1. So we have equation 1, y equals 3x plus 4, and equation 2, 4x plus y equals -3. So notice that we have one of the equations is isolated for y. So that's equation 1. So what we're going to do, it says circle both y's and box what y equals. So we're going to then substitute the boxed expression in place of y in the other equation that the arrow points to. So here's our 3x plus 4. I box that in. I replace it with the y that's circled in the second equation. So it'll be 4x plus, in place of y, I put 3x plus 4. Step 2, solve the equation. So I have 4x plus 3x plus 4. So 4x and 3x is 7x plus 4 equals -3. Then I'm going to subtract 4 from both sides. So I have 7x equals -7. Divide both sides by 7, and x equals -1. Then what I'm going to do is substitute the numbered value of x into y equals 3x plus 4 to get the answer for y. So y equals 3 times -1 plus 4. So that gives us -3 plus 4, which is +1. So the solution is x is -1 and y is +1. We can also go and check this. So we could use this equation right here to check it. So 4 times x, 4 times -1 is -4, plus y is 1. Is -4 plus 1 equal to -3? Yes, it checks out just fine. All right, let's go ahead and look at example 2. So solve the linear system by using the substitution method. Remember to circle both x's because this one is isolated. So here's an x and here's an x. And what you're going to do is take this and you're going to put it in place of x right there. So you're going to have 2 times your x. So it'll be 2 times your x equation is 4y plus 1, or the expression, not the equation, minus 3y equals 12. Then what you're going to do is you're going to solve it. So we're going to distribute. So 2 times 4y is 8y. 2 times 1 is 2. Minus 3y equals 12. So then we're going to combine our like terms. So that'll give us 5y plus 2 equals 12. Subtract 2 from both sides. 5y equals 10. Divide both sides by 5. And y is equal to 2. So we can go ahead and put our 2 right here. So now it says substitute the number value of y into x equal 4y plus 1 to get the answer for x. So x equals 4 times 2 plus 1. So 4 times 2 is 8 plus 1 gives us 9. So then again, we could go ahead and check it. So we could use this equation right here. So 2 times 9 is 18 minus 6. Does that give us 12? 18 minus 6. So this does check out. So we know for sure that the ordered pair 9, 2 is a solution to both of those equations. All right, so now we're going to practice on 3 and 4. So we're going to do everything without any hints. So problem 3. We have the y is isolated, so I'm going to circle this here, circle that there, and then I'm going to box this in. So what I'm going to do is I'm going to take that top equation. I'm going to go 4x plus, in place of y, I'm going to put the expression 5x minus 3. And that equals 24. So this will be 4x plus 5x minus 3 is 24. So 4x and 5x is 9x. Minus 3 is 24. I'm going to add 3. So 9x equals 27. Divide by 9. So x equals 3. And then I'm going to substitute. So I'm going to use this equation that I boxed in. So y equals 5x minus 3. So y equals 5 times 3 is 15 minus 3, which is 12. And then we can go ahead and check that. So we're going to have, I'm just going to use that top equation there. This one right here. So 4 times 3 is 12. Plus your y is 12. Does that give us 24? Yes, it does. It checks out just fine. All right, let's take a look at problem 4. So x is isolated here. Okay, so I'm going to circle where both x's are. I'm going to box this in. I'm going to put that in place of that x. So it's going to be 2, and then in place of x, I'm going to put y plus 3 minus y equals 5. So one thing to double check is just make sure that you have the same variable in your equation after you substitute. If you don't, if you still have 2 different ones, like an x and a y, then you've substituted incorrectly. So we're going to hippity-hoppity. So 2y plus 6 minus y equals 5. 2y minus y is y plus 6 equals 5. Minus 6 minus 6. So y equals -1. Then we can substitute. So we're going to use this equation. So x equals, our y is -1 plus 3. So -1 plus 3 is 2. And then we're going to check it. So we have, I'm just going to use that bottom one. So 2 times 2 is 4. Minus a -1, which would be plus 1. Does that give us 5? Yes, it does. And it checks out just fine.